Hello everyone, and welcome to the Unit 4 review packet where we're going to talk about exponential functions. If you're one of my students, we're watching this hopefully to get ready for the test, to be prepared for that coming up very soon. If you are not one of my students, just hope you find this helpful. Hopefully you'll find this at least a little bit useful in whatever class, whatever state or country you find yourself in. So let's start with number 1 though. Determine whether the sequence is arithmetic or geometric. To know if it's arithmetic or geometric, there's either a common ratio or a common difference. So if we look at these terms here, clearly not adding or subtracting by the same thing every time. It looks like we might be dividing by the same thing or multiplying by the same thing every time though. So if I just take the second and subtract the first, or the second and divide by the first, that's going to find me that common difference or common ratio, as long as the difference or ratio here is the same as it is between the third and the second. And so if I check that out, I've got negative 32. If I put this into a calculator, divide by 128, it gets me negative 1/4 or negative 0.25. And then if I do the same thing with the third divided by the second number that shows up there, so 8 divided by negative 32, I get the same value. That means you have a common ratio, and that means it is geometric. So I could say that this is my ratio or my R value. To write an equation that describes the behavior, then we take this general form, so this AN equals the initial value times R to the n minus 1, but we change some stuff around here. So the initial value, I'm going to erase some things there, or the first value in my table is actually 128, but that goes with an x value of 0. So this is going to change here, and I know what my R is. I'm saying 128 is my initial value. I know my ratio from here was negative 0.25, and then I know that I'm writing n and then minus whatever this number is. Since it's 0, I would write n minus 0, or I could just leave that as n, more preferably. So this we leave like that. Since you're just subtracting 0 from n, we can just leave it as n. And then if the pattern continues, predict the sixth term in the table. So plug in 6 for n, and then if you plug this into a calculator all at once, so 128 times this in parentheses to the 6th power, we should get, it looks like 1/32 if you have that as a fraction, or 0.03125. So I just tried that in a calculator there, end up getting that number. So that's going to be the 6th term in a sequence, or in that particular sequence. Let's look at the next batch of problems here. There it goes. So determine if this one is arithmetic or geometric. This one looks like we're not multiplying by the same thing. It looks like we're adding the same thing each time. So the same idea holds though. Do the second, and now since it looks like adding or subtracting, I'm going to subtract instead of divide. So do the second minus the first. That's going to be minus a negative, would be the same thing as that, plus 13, which would be 6. And then negative 1 minus negative 7 would be the same thing as negative 1 plus 7, which would also be 6. So on this one there's a common difference. We have a D value, or a common difference. Yikes, what's going on there? So we have a D value of 6. That was really strange. I don't know why that little slash was in there. I tried to circle around that. But write an equation that describes the behavior. Now we've got, if it's arithmetic, we can use point slope form. We have y minus y1. So I can say y minus, and then I can just take my pick of values here and just decide where to go from there. So I'll just use the top one there. It might have been slightly easier to use 4 and negative 1, or 5 and 5, but I could use those if I wanted to. You could use those if you want to. I'm just going to use, oh come on, I'm just going to use this here instead. Hopefully my pen is not going to keep jumping around like that. So y minus negative 13 would be the m value, which is the same as your d value. So the slope is the same thing as your common difference. And so we're going to have 6 times, and then x minus that value there. X minus x1 would be x minus 2. And then we want to solve this for y. So get y by itself. You can distribute that 6 to both parts there. So 6x minus 12. Subtracting 13 from both sides there gives you your final equation. Y equals 6x minus 25. And then if we're going to use that to predict the 15th term of the pattern, just plug in 15 for x and that'll give that to you. So y would equal 6 times 15 minus 25. That would be 90 minus 25, which would be 65 right there. So that would be the 15th term in that pattern if you kept going up. Let's see from here. Determine whether a sequence is arithmetic or geometric and justify your answer. So this one, it looks like we're not adding the same thing. It looks like we're multiplying potentially by the same number. So let's do 1 divided by 0.5, and that would be 2. And then 2 divided by 1, the third divided by the second. 2 divided by 1 would also be 2. So this looks like your common ratio in this case. An equation that describes behavior, we've got a of n would equal the first term listed in the table times the ratio, and then to the n, and now it's going to be minus 2 since you're starting at 2 in that table right there. So that would be an equation that describes the behavior. And then from there, predict the 14th term. So we would be plugging in 14 for n. If you plug in 14 minus 2, that's going to be 12. So you could write this, if you wanted to, as 0.5 times 2 to the 12th power. Instead, you could plug either one of these here or here directly into a calculator, and it looks like that would give you, plugged in correctly, I got 2048. If you do see any mistakes on here, feel free to comment there. If you're the first one and one of my students, I'll give you some Wagner bucks for that. Let's check out number 10 here. So use this to determine the following. This right here as a decimal is the same thing as 0.8. So in this growth or decay form, we want excuse me, still getting over a little cold there, so I might have some sniffles here and there. So f of t, we could say f of x instead if we wanted to, but I'll go with f of t because that's the way at least I had initially taught it. We have 1 plus or minus something in parentheses, but the 3 stays out in the front, and then there we go, it's still skipping around on me a little bit, but this would be 1, and to get a number that equals 0.8, I would have to subtract this number from 1. That gives me 0.2. So 1 minus 0.2 is 0.8. Therefore, this is going to be the same thing as this, and I'm just changing x to the t power. So this value right here, altogether, this is or equals the same thing as 0.8. So right here, that's why I put 1 minus 0.2 in there. So identify whether the model is growth or decay. You're subtracting from 1. If you have a number less than 1 inside of there, that's going to be decay. And the growth or decay rate, move that decimal 2 spots to the right. That would be 20% decay. And your initial value is the value out there in front of the parentheses. So 3 is your initial value. For 11, rewrite the ratio in growth or decay form once again. So this number right here, looks like we're going to have f of t, we can say that, or we could say f of x, or whatever notation in the front you decide to use. But this is really what I really care about, is getting this part right. So 11.3 stays the same. It's 1 plus or minus something. In this case, it's going to be plus, because 1 plus 2.4 is 3.4, the number that's right there. So 1 plus 2.4 goes there, and then since I use t here, I have to use t here. Identify if that's growth or decay. that looks like it will be growth because we are adding to 1. We have something bigger than 1 here in the parentheses. So this is going to be growth. And it is, if you move that decimal 2 spots, 1, 2, that's going to be 240% growth. And then identify your initial value. The number out in front is our initial value there, 11.3. For number 12, a car purchased for $24,000 is expected to lose value or depreciate at a rate of 8% per year. After how many years is the car first worth less than $5,000? So we're saying this is like your f of t, your function value. This right here is your rate, 0.08. This right here is your initial value, which we've been calling A1, but A0 would actually also work and technically be a little better even. So if we plug these in though, we're saying A1, we got our R, we've got our f of t. So we have 5,000 is going to equal our initial value, 24,000, times 1, and we are depreciating. So we're going to be losing value, 1 minus 0.08 to the t power. And then if you're one of my students, this is something, if you're Algebra 2, you know about logarithms, and you could solve this with logarithms. But if you're in Algebra 1, you won't have learned that by this point. If you're one of my students, we haven't learned that. So here we use that table button on the calculator that we learned about. So type the right side of the equation you see here. Type that into the table button on your calculator. And then scroll down until you see 5,000 or less, or until you see less than 5,000 in this case. And the first time that happens, I've worked this out beforehand, so the first time this happens was at t at 19 years. So if you plugged in 19 here, in terms of whole numbers at least, this is the first time, the first whole number of years where the value of the car is going to drop below 5,000. For number 13, your baby brother, poor baby brother's got 50 million bacteria in his left ear, but the penicillin is going to kill that bacteria 8% every hour. So how many bacteria will be in your brother's, I should say brothers, so in your brother's ear after 8 hours? If we've got the general formula, we say A of n would be the initial value, gross 50 million bacteria. So 50 million, and then times 1, and it's going to kill 8%. This is going to be R of 0.08 once again, just like it was up here. And we are subtracting again because we're killing the bacteria. So subtracting 0.08, and then this is going to be to the, since it's to, we're saying 8 hours, this is your time right here. So we're saying to the 8th power. And when I had typed this directly into a calculator, I had gotten 25 million, approximately this many, 25,660,944 bacteria. Lovely. So still over half the bacteria left after 8 hours, but after 1 day, this is going to be the same thing as 24 hours. Our equation is given to us in terms of hours, so we need to make sure that we use hours and not days when we plug in a t value. So this would be this I could have written as A8 instead, so now we're talking A24. So after 24 hours, 50 million times 1 minus 0.08 to the 24th power. Plug that into a calculator, and you get approximately 6,758,929 bacteria. Moving on from there, let's check out number 14. So a watch purchased for $1,500 expected to gain value at a rate of 4% a year. So this one, your R value is 0.04. Move that decimal 2 spots to the left. It's always 2 spots to go from a decimal to a percent or percent to a decimal. This is going to be our initial value right here. And then after how many years is the watch first worth more than $3,200? So we're saying, when is this true? We're saying, checking 1,300, when does that actually equal 1,500? And then 1, and we're saying gaining value, so plus 0.04 to the t power. Here again, we use the table on your calculator. If you don't know logarithms, like we don't, if we're one of my Algebra 1 students, we don't know what those are yet, so we're going to use the table, use the technology to help us figure this out. We want to figure out where this first worth more than that. So if you type in whole value numbers for t, or you plug this right side into the table functionality in your calculator, and you keep scrolling down until you get to, it looks like on this one, 20 years. So when you plug in 20 for the right side, that's the first time that you get a number over here that's at least, or I should say more precisely, more than 3,200 here. So type this right side into your table function in the calculator. Keep scrolling down until you see something more than 3,200. We're saying t is 20, and this is in terms of years, 20 years. And then how much will the watch be worth in 7 or after 7 years? So we could plug in 7 into the function. So we're saying 1,500 times 1 plus 0.04 to the 7th power. Plugging that into a calculator gives you $1,973.90. That's rounded off to the nearest cent. If we're talking money, that's the way to go. We want to round off to the nearest cent. For 15 and 16, this one we're dealing with compounding stuff. So I had shown you, if you're one of my students, I had shown you this compounding formula. We start with our initial value here. I had written it as a 1. Technically it should be a 0 for the initial value, so I'll write it like that instead, but it still means exactly the same thing as what we were doing before. But 1 plus or minus, and this is r over c, and then to the t times c, or to the tc power. So this, I had said A1 if this is the first year that you're watching this and I'm using this video, but A0 is technically what we should have there. But A0, that just represents initial value. So our initial value here, 4,500, and this is saying at the end of 35 years. So t, 4,500 is your initial value, and your 8%, that's r of 0.08. Compounded quarterly means that c would equal 4 right there. So we just are plugging in 35 for t. Initial value out in front there is 4,500, and we are on this one, we're gaining money, we're adding interest to this account, so plus 0.08, and then that's to the 35th power. However, we need to divide this part by the c part, so divide that part by 4 and then multiply this part by 4. Plugging all this into a calculator, doing that correctly, yields this as your final answer. So we should have 71,000, not bad at all, $71,984.10. So you drastically increase the amount of money you had in the account. This should be dollars, so I'll write a $sign in front of the 71 part there. And then for 16, you deposit 3,400 in an account, still using 35 for your t. This is your r value now of point. To move it 2 spots, it's going to be 0.0625, and this is your initial value right here. And we're compounding monthly on this one, so that would be 12 times a year, so c equals 12 in this case. So you have f of 35 equals the initial value, 3,400, times 1, and we're adding, once again, it's interest, so we're increasing the amounts in the accounts, 0.0625 to the t power to the 35th power. But again, we need to divide by how much we're compounding, how many times we're compounding. So this is divided by 12 here, and then this is times 12 there. Plugging this into a calculator yields 30,132.33. Good idea to check with your own calculator and verify that you get the same thing. Make sure that you know how to type these things into the calculator to get the right answer. Number 17 next. On the first day, the price of an item was $32, and the second day the price was $25.60. So if the rate of change was linear, what would be an equation for the price? If it's linear, it's going to be a common difference instead of a common ratio. So we would take the second term minus the first. If we're saying the price of an item day 1, so this is like 1 going with 32, a 2 going with the 25.60. Subtracting these things, however, gives you negative 6.4, excuse me. So if we do y minus y1, use this as your x1, y1. So y minus 32 would equal the slope, or the common difference here, of negative 6.4. That's going in right there, times the quantity x minus, and 32 goes with 1. We're saying that's on day 1. So solve for y from here. Negative 6.4x plus 6.4. You can add 32 to both sides. We distributed the 6.4, adding 32 gives me a final equation, y equals negative 6.4x, and then adding these two numbers together, 38.4. And for 17b, if it was exponential instead, that would mean you'd have a common ratio. So we need to find an r value. We need to divide these two numbers instead. So if I divide 25.60 by 32 instead of subtracting the 2, I'm going to get 0.8 or 0.8 for my ratio value. So now this number, we plug it into the a of n formula. Our initial value here is what we're starting with, 32. And then times the ratio going in here, so times 0.8, and then to the n minus 1 in this case, since we're starting with an x value of 1, this needs to be a 1 after the n. And that's it. We're just coming up with the equations. We're not actually figuring out any of the future values from there, just coming up with the equations. So number 18, now we're going to start some multiple choice type problems, working our way through these types of problems. So if we have multiplication like this, we are going to add the exponents. Therefore, your answer should be x to the 9th power on this one. X to the 9th power, choice D, so circle that one. If you're dividing things with same base and powers, we can subtract those exponents. So this would be 4 to the 4th power, and 4 to the 4th power would be 16 times 4 more, 64 times 4 more, 256. So this is, remember, the same thing as saying 4 times 4 times 4 times 4. So that is choice C on that one. For the next one, we're trying to get the bases to be the same. We're dividing things with the same base over here. So I could say that on the left side of this equation, I would have 2 to the 2x minus 2 minus this whole thing. If I subtract the whole bottom part, that will change the sign here and here. So this would actually become plus 2x plus 2. Subtracting that part, distributing the negative, makes both of those positive. So that's that left side, and then this would equal on this side, 2 to some power has to be 16 the way we're setting these up. We're not going to try to trick you. 2 to the 4th power is 16. From that point, the bases, you could get rid of those and just set the exponents equal to each other. That's the only way that the left side could equal the right side. If the bases are the same, the exponents have to be equal. If we combine like terms here, 2x plus 2x is 4x. Negative 2 plus 2, those two terms would cancel out. So you just have 4x equals, and then you have 4 on this side. Dividing both sides by 4, you get x equals 1. Final answer on that one, choice C. For 21, you could either reduce the 4 and the 2 right away, or you could wait until later. I'll wait until later. If you want to reduce now and just call it 2a to the third divided by b to the fourth, that works just as well as what I'm about to do. But if we're taking a fraction to a power, you can take each piece and raise it to the second power, since it's a 2 right there. So we have each piece, make that 4 a little better looking, that's better, to that power. And then we have here powers raised to powers. This is like 4 to the first raised to the second. So you have 4 squared, multiply 1 times 2. And then here you have a to the third squared. That would be a to the 3 times 2, or a to the 6th. On the bottom, it's like 2 to the first squared. So that's 2 to the 1 times 2. That's 2 squared. And then this power to a power, we're going to multiply those powers as well. So we have b to the 8th. This would be 16a to the 6th on the top. This would be 4b to the 8th on the bottom. You can reduce 16 and 4. That can become a 4. And then a to the 6th, b to the 8th. Since they're different bases, you have to just leave them just like they are. So nothing else can cancel out. Nothing else can reduce. That should be an 8. Sorry about that. There we go. So 4a to the 6th, b to the 8th, looks like that is choice A right there. 22. We have the same base here and here. We can subtract those powers. So this would be x to the 6 minus 3. And right here, same base. Subtract the powers. 8 minus 4. That's going to be x to the third, y to the fourth. And that is choice D right there. 23. This is like 2 to the first, and then x squared, y cubed, all of that to the third power. Power to a power, we're going to multiply those powers. So in a sense, you're thinking of distributing that power to each piece right there. So this would be 2 to the third. This would be x to the 2 times 3, or x to the 6th. This would be y to the third cubed, so that's 3 times 3 for the base there. That's 9. 2 to the third power is 2 times 2 times 2, which is 8. So our final answer on this one looks like this. 8x to the 6th, y to the 9th. That is choice B. For 24, you're dividing powers with the same, or dividing things with the same base. So just subtract those powers. 6 minus negative 3 is the same thing as 6 plus 3. So that one simply is a to the 9th power. And it looks like that is choice B on that one. Then for 25, a couple different ways we could approach this one. We could cancel top to bottom first. Anything you see on the top that can cancel out with something on the bottom, you could take care of that first. I'm going to do the other way though. I'm going to just multiply straight across and then reduce after that. So 12 times 7 would be 84. X times x to the 5th would be x to the 6th. Add the powers there. Y times y squared. That's like y to the 1st times y to the 2nd. Add the powers, y to the 3rd. On the bottom, 7 times 4 is 28. X to the 4th, and then just a y. So we just have x to the 4th, y on the bottom. Both of these can be reduced by a factor of 28. So 84 divided by 28 is actually 3. So you could just rewrite this as 3 and then subtract the powers here with the x's. So that's 6 minus 4, which is 2. And then this one is like y to the 3rd, and this is like y to the 1st. Invisible 1 is there. So that would be y squared. And that one looks like gets you choice A. So if you wanted to cancel top to bottom, you could make the 12 in the the 4, a 3, and a 1, and you could just cross off the 7 and 7 here and here, and then go across from there, reduce from there. There's more than one way to do this, but I think this way probably makes the most sense, at least right now, to the most students. So I'm showing you this way. If you know other ways to reduce that make sense to you, you can use those ways as well. 26. We are taking these exponents, subtracting them since we have the same base and we're dividing things. So this would be x to the 6y plus 4 minus that whole quantity again. So minus the whole quantity just means you change the sign on both of those. So we'd have minus 3y plus 2. Subtracting the whole thing changes all the signs. This would be not reducing but combining like terms. You'd have 3y plus 6 in the exponent, and that looks like it is choice C. On 27, we want to get the same base on the left and the right, so it looks like I want to write this as a power of 2 somehow, and then these ones, since I'm just multiplying these two things, I just add the powers. So I would have 2 to the negative 3x plus x would be negative 2x, and then negative 5 minus 9, or plus a negative 9, is the same thing as negative 5 minus 9, which would be negative 14. And then 2 to the 16th power would be 2 to the 4th, or not 2 to the 16th, 16 would be 2 to the 4th power. The bases are now the same, you can cross those out, and then you have negative 2x minus 14 would equal positive 4. Add 14 to both sides, get negative 2x equals 18, and then divide by negative 2. There's your answer of x equals negative 9 in that case. So that one is choice D. 27. Is the one I just did. I'm sorry. I'm looking at the wrong thing in my previous work. So 28, that's the one I'm on. So I have 28. This would be, we're multiplying all this together. So find all the g's, add the exponents together, and then find all the y's and add those exponents together. So this I could rewrite with the like terms and the exponents combined. This would be 5a plus 5, and then this one would be, I could leave it like that, or I could write it as 2a plus 3. If you look at your answer choices, it's written like this instead. So choice B, that's the one, that's the answer choice that matches up. And then finally, some scientific notation problems. This one, we want to see how many spots we have to move the decimal place. So 1, 2, 3, 4, 5, 6 spots to move that decimal place to make a number between 1 and 10. And it is going 6 spots to the right. Anytime we move the decimal to the right, we're subtracting 1 from the power each time we move it 1. So it's a negative 6 power. You can also think of this as being a small number, a number less than 1. Those go with negative powers. And then here, if any time you move to the left, the decimal, you're going to add to the power of 10. So this is going to be a positive 4 power. And so if we write that in scientific notation, it looks like this: 7 times 10 to the negative 6. That's the first part. And then 9 times 10 to the 4th is that other part. Performing the operation, I'll box that in. That's the final thing for part A. That just means you're multiplying them together though. So 9 times 7, that's 63. And then we're just multiplying, so we add the bases, or add the powers, excuse me. Negative 6 plus 4 would be negative 2. So that is what it looks like after we perform the operation. And then we want to move that decimal from here to there in final scientific notation form. So we would have 6.3. Moving to the left means we add 1 to the power. So this would be negative 2 plus 1 would be negative 1. That is the number in scientific notation. Number 30. looks like this. The top part, you have to move it 1, 2, 3, 4 spots there to the left. So we're adding 4 to the power of 10. And then here, 3 spots to the right, subtract 3 from the power of 10. So this is the same thing as saying 2 times 10 to the 4th over 4 times 10 to the negative 3. That is equal to 0.5 times 10, and then we are subtracting these powers. So 4 minus negative 3, since we're dividing the parts here, we're subtracting the powers. That would be 4 plus 3. After you do minus a negative, that would be to the 7th power. And then changing that to scientific notation, that front number needs to be between 1 and 10. So we move that 1 spot that way, leaving us with 5 times 10. And we move it 1 spot to the right. Moving to the right means we subtract from the power. And that would be then 5 times 10 to the 6. We just moved it 1 spot, so subtract 1 from the power there. And then finally this one, rewrite that in scientific notation. 1, 2, 3 spots to the right, that's a negative 3 power. 1, 2, 3, 4 spots to the left, that's a positive 4 power. This would be 5 times 10 to the negative 3. This one would be 2 times 10 to the positive 4. If we multiply the numbers out in front together, that's going to be 10. And then add the powers bases, or add the powers together with the same bases here. So we have 10 times 10. Adding that together would be to the first power. But we want a number between 1 and 10, and it has to be a little less than 10. It can't actually be 10 itself. So this is our final answer here. This is our final answer here, but this is not in a final scientific notation form. So we need to move that decimal 1 spot this way for that. And then we would have 1 times 10, and we're moving 1 spot to the left. That means we are going to add 1 to our power. So this is 1 times 10 squared for the final answer there. And I believe that is it for us here. Let's just double check that. Nope, I actually have a couple more. So sorry about that. We've got 90,000, 1, 2, 3, 4. So we're going to move this 4 spots that way. That would be a positive 4 power. And this one, we're going to move 1, 2, 3, 4, 5, 6 spots that way. That'd be a negative 6 power right there. So that, written in scientific notation, 9 times 10 to the 4th divided by 3 times 10 to the negative 6. Performing the operation, this would be 3, and then times 10 to the, we're subtracting the power, so 4 minus negative 6 is the same as 4 plus 6, which is not 6, it is 10. There we go. And then 3 times 10 to the 10th, that is already in scientific notation. This number is between 1 and 10, so you can just rewrite what you have there for part C, and that's it. And then finally, this is the last page here. So complete the table and plot the points for this equation. So what we have here, this is f of x equals 2 to the x power plus 2. If you're going to plug in negative 3 in for the x value right here, what do you get spitting out for the f of x value, or for the y value, in other words? So if you do that in a calculator, I'm just going to do that quickly a second in a calculator, and I'll write these in for you. Okay, so I've done these things in a calculator, written them out here. You're just plugging in negative 3 first in for x. That would give you 1/8. It's actually 1 over 2 to the positive 3. If you have a negative power, remember 2 to the negative 3 would be the same thing. You could write that as a fraction over 1. We put any negative powers, we switch the place in the fraction, make the power positive, so it looks like that. So that's 1 over 8. We're adding 1/8 to 2. So 1/8 plus 2 is 2.125. If you do the same thing with -2, you get 1/4 instead of 1/8. You add 1/4 or 0.25 to 2, you get 2.25. Same thing happens with -1, that'd be 1/2 plus 2 or 2.5. Anything to the 0 power is always 1, so you'd have 1 plus 2 here for 3. 2 to the first is 2, 2 plus 2 is 4. 2 to the second is 4, plus 2 is 6, and then 2 to the third power is 8. 8 plus 2 is 10. So there's all your values there, and then from there, just plot those points. So -3, and then we're going, here's 2, it's already labeled on the graph for you, so just go a little bit, tiny bit higher than 2. Same thing for 2, but just a skosh higher than what you had gone there. Then 2.5 would be right about there. 3 is halfway in between the 2 and what would be the 4 right here. And then going over 1, we'd be at 4 right there. Going over 2, we'd be at 6 right there. Going over 3, and go up to 10. So this would be 8, this would be 10. Connect those with a curve. And that curve would continue going this way. This would be an exponential growth because we are getting bigger or getting higher as we move from left to right. So that truly does it for us now here on this review packet. 33 problems there that you went through. Hopefully you found this helpful. If you found it helpful, feel free to like the video. I always appreciate those likes and spread the word. If you have anybody that you know that might find this helpful, feel free to share it with them. Leave any comments if you saw any mistakes or just want to say thanks or just want to say hello. Feel free to do all those things. Go back, rewind, pause, reflect, ponder, and review as needed here. Make sure you're ready for the test if you're one of my students coming up very soon. Hope you do really well. Hope you study hard, and hope you show what you know and do the best you possibly can on the test you might have coming up. Other than that, have a good day, and I will see you guys later.